We will recall first, what is logic?
Logic is the study of the rules which underlie plausible reasoning in mathematics, science, law, and other disciplines. Symbolic logic is a system for expressing logical rules in an abstract, easily manipulated form. In symbolic logic, a letter such as P or any kind of letter stands for an entire statement to represent the statement. Symbolic logic uses a sign to connect two statements to form a third statement. These basic logical operators are negation, which read as not, conjunction, read as and, disjunction, read as or, conditional, read as if and then, and biconditional, which read as if and then. In a symbolic logic, truth tables are useful formal tools for determining the validity of arguments.
A switching network consists of wires and switches that can open or close. As you can see here, there is two horizontal line which represents a wire, and between it is the P, where is the switch that can be open or closed to control when to turn the lights on or off. Switching networks are used in many electrical appliances, telephone, equipment, and computers. It is not using symbols, instead illustrations. We have terminals here, the dots. Essentially, the goal is for the current or for the electricity to be able to flow from one terminal to another. A switch is act as a gate. If the circuit or the switch is open, the current cannot flow to another terminal. On the other hand, if the circuit or the switch is closed, the current can flow to another terminal. Switches can be connected in two ways. These are series connection and parallel connection. If you have series connection, there is only one way for the current to flow. But if you have parallel connection, there is several ways for the current to flow.
Let's see the example figure of switching network. The example shows switching network that consists of a single switch P that connects two terminals. An electric current can flow from one terminal to the other terminal provided the switch P is in a closed position. If nagwonder mo nga nung nainganin na siyang porma, it is just switching network doesn't uses symbols anymore. Instead, it uses illustrations. For AND, this is the symbolic form and this is the illustration form, and it will be a series network. This series network is closed if and only if both switches are closed. We will use P and Q to denote this series network because it is analogous to the logic statement P and Q, which is true if and only if both P and Q are true. For the OR, this is the symbolic form and this will be the illustration form. And this will be a parallel network. This parallel network is closed if either P or Q is closed. We will designate this parallel network by P or Q because it is analogous to the logic statement P or Q, which is true if P is true or if Q is true. So, for us to understand easily the illustration, let us convert it into a symbolic logic way. So, first is this one. So, this illustration shows parallel network, which means OR, so we write R or P. Next is this one. We also see that this is a illustration of a parallel network, so we write R or negation of P. In the middle, this is an illustration of a series network, which means AND. So, we put AND Q in the middle. So, if we combine it together, this is R or P and Q. R or negation of P. Since we got the symbolic logic of the problem, sunodon ra siya og answer.
This section will highlight how symbolic logic is used in modern society. It is common knowledge that logic has practical application in numerous fields, including computer science, mathematics, and philosophy. With lemmas and fruits, mathematics teaches logic virtually as an extension of algebra or calculus. Additionally, computer science emphasizes its use in teaching, particularly in terms of enhancing programming capacity or creating thinking machines. But philosophy, which logic has always been a crucial component, takes slightly different path when it comes to logic, because different sources are there for its primary priority. A digital computer is a programmable machine that processes binary data, which is represented by binary number system. The simplest number system employing positional notation is the binary system. A binary number system uses only two symbols or digits, namely 0 and 1.
Can we use logic to describe circuits?